All right, everyone. Practice tests for the trig unit, test 1, part 3. So we're doing another example here. So here we have 10 cos 2x minus 8 cos x plus 1 equals 0. Right away, I see this as an issue because cos 2x and cos x are not the same. But is there a way to kind of write them? Is sort of, having the angle part being the same? And yes, there is. If you take a look at the trig identity, so one of the trig identities for cos 2 theta is, well, there's 3. And the one I'm going to look at is this one here, because I've done a lot of practice with this. So cos 2 theta is equal to 2 cos squared theta minus 1. So this is going to be 10 bracket 2 cos squared x minus 1. And then obviously we have the rest of the question here. We're just going to multiply this out. 20 cos squared x minus 10. Oh, did I make a mistake there? Oh, I did make a mistake. That's okay. I'll just fix it now. Okay. So here we have 20 because 2 times 10 is 20. And then we have minus 10 because 10 times minus 1 is 10. Or negative 10. So let's collect like terms. We have 20 cos squared x minus 8 cos x minus 9 is equal to 0. If you can't see it, this looks awfully like a quadratic equation, except we're using cos. So what you need to do is just have a simple let statement. Let cos x be, and pick a letter you like. Let's say w. So let cos x be w. So we're going to rewrite this in terms of w now. So 20 w squared, because cos x times cos x is cos squared x, and then that's just w squared, minus 8w minus 9 equals 0. At this point, this is a grade 10 problem. It's literally quadratic. Whenever you have a quadratic, use quadratic formula. You can try factoring it if you want. I would just use a quadratic formula. So I really don't want to do it the long way, but I guess I'll do it just to show you guys. So quadratic formula is x is equal to negative b, which in this case negative 8. So it's 8 plus or minus square root b squared. So it's 8 squared or negative 8 squared. Doesn't really matter. It's going to be 64 either way. Minus 4 times a, which is 20, times c, which is 9, all over 2a, which is 2 times 20. So this becomes 8 plus or minus square root 64 plus 200 minus 2180. Pretty sure I did that right. No, sorry, I apologize. So that's going to be 180 times 4. I apologize. So what's that? 800 minus 80. So 720. Question mark. I should just use a calculator. Yeah, no, that looks right. Okay, over 40. And this becomes, let's see. What's the square root of, what's 720? So 64. And the square root of that is 28. So the square root of 20 plus 64, which is 784, is 28. So this makes our lives a bit easier. So our two solutions are going to be 8 plus 28 over 40. 40, which is 0.9. Easy enough. And then the other one is going to be 8 minus 28 over 40. And that's just going to be negative 20, and that's negative 0.5. All right, so we solved it. We solved for x, or I guess, sorry, not x, because the variable that we used is w. So we solved for w. So w is equal to 0.9 or negative 0.5. Now w was equal to what? Our late statement was cos x. So in reality, this is cos x is equal to 0.9. That's one equation. And cos x is equal to negative 0.5. That's another one. So now we are going to solve these two mini equations. And I'm sure we've had a lot of practice with this. All you have to do is just take the inverse cos of this value, and that's your answer. And remember, each trig function usually has two solutions, depending on the period and the range. But yeah, let's see. So shift cos of 0.9 gives me, this is in degrees, so I'm going to change it to radians since we want radians. So let's do this again. So shift cos 0.9. And I get 0.45 radians cos x. And remember, this is our cosine law. Sorry, not cosine, I apologize. This is our cos ratio. And cos is positive in which quadrants? Cos is positive in the first quadrant and in the fourth quadrant. And we know that the angle inside our triangle is 0.45 radians. That means the angle here is also 0.45 since it's the same triangle. So our second principal angle for that terminal arm is going to be 2 pi minus 0.45. And 2 pi is just 2 times pi minus 0.45, which is 5.83 radians. So these are our two answers for our first equation, 0.45 and 5.83. As for our second equation here, cos x equal to negative 0.5, well, we take the inverse cos of negative 0.5. Let's see what we get. Shift cos negative 0.5. I got 2.09 radians. So which quadrant is this in? Well, let's think about that. Let's think about that. Which quadrant should I expect it to be in? The ratio in this case, cos x is negative. So if you're using our CAST rule, CAST rule, I expect my terminal arms to be in not quadrant 1, not quadrant 4, but quadrant 2 and quadrant 3. And 2 radians is not the same thing as 2 pi radians. Remember, 2 pi is 6 point something, 6.28. So this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So pi is 3.14. This value, 2 point something, is less than 3.14, and it's bigger than half of pi, which is 1.6. So it's somewhere in the middle, somewhere in quadrant 2, which is something we expect. So this value here is 2.09 radians. So what is the value that's inside our triangle here? Just do pi minus this value, and you'll get that blue angle. So what's pi minus 2.09? Easy, just plug that into your calculator. Shift pi minus answer, and you get 1.05. I'm rounding to the nearest 2 decimal places. So 1.05 is here, 1.05 is here, and our second terminal arm is going to be pi plus 1.05. So take 1.05 plus pi, and you get 4.18. So pi 1.05. 4.19 radians. So that's one answer. And that's another answer. So this whole example from the beginning, from here, when you convert it into a quadratic, you have 2 possible solutions with your quadratic, and then because there's 2 equations, each cos equation gives you 2 solutions per equation, so you have 4 answers in total. And there you go. That's how you do it. Hopefully that was useful. Take care, everyone.